Okay, great. So the half angle formulas are pretty cool because they all come from the cosine of 2 alpha formulas. So let's see. We can write cosine 2 alpha in terms of just cosine. Let's see. We've got cosine of 2 alpha is 2 cosine squared alpha minus 1. And let's solve this equation for cosine 2 alpha. So we're going to add 1 to both sides. Divide both sides by 2. And I'm going to write that as 1/2. Because I know that I'm going to have fractions inside. And dividing by 2 is the same as multiplying by 1/2. So now I'm almost there. So we've got 1/2 times cosine of 2 alpha plus 1 is cosine squared of alpha. If I want to solve for cosine alpha instead of cosine squared alpha, I need to take the square root of both sides and put in a plus or minus. So we've got that cosine alpha is cosine 2 alpha plus 1 and square root of that whole thing. But now we're going to do the happy thing that we can do with math. We're going to let alpha equal beta over 2, which means that 2 alpha is 2 times beta over 2, which means 2 times alpha is just beta. And that enables us to write the formula that's up top as cosine of, let's see, we said that alpha was beta over 2 equals plus or minus the square root of 1/2 times. We said that cosine 2 alpha, we said 2 alpha was beta. So we get cosine of beta plus 1. So the formula for the cosine of beta over 2 is going to be plus or minus, and that depends on the quadrant of beta over 2. 1/2 times the cosine beta plus 1. And we can see that that is indeed the formula. Plus or minus the square root of 1 plus cosine alpha over 2. And the reason that we're putting the plus sign first is because that we want it to match the sine formula. So let's do the same thing with sine. We're going to use that the cosine of 2 alpha can also be written as 1 minus 2 sine squared alpha to find the formula for sine of alpha over 2. So we've got cosine of 2 alpha can be written as 1 minus 2 times the sine squared of alpha. We're going to solve for the sine of alpha, just like we did before with the cosine. I guess equaling them. Thanks, Ben.
No problem.
So we're gonna, let's see. We're gonna subtract 1 from both sides. We want to get sine alpha eventually. So we've got cosine of 2 alpha minus 1 equals the negative of 2 times sine squared alpha. I'm going to multiply both sides by a -1 to try to clean up these signs, these SIG ends. So let's look at the right side first. A negative times a negative is positive. So on the right side now we have 2 sine squared alpha, and it's a positive 2 sine squared alpha. On the left side, we've got a negative cosine 2 alpha, and negative times negative is a positive 1. And usually with anything that we can just decide, we'd like the positive thing to come first. So I'm going to write this left-hand side as minus cosine. And now we're going to do the same things. We're going to multiply both sides by 1/2 to get rid of the factor of 2 that was on the right. And now we've got, let's see, 1 minus cosine 2 alpha times 1/2 is equal to the sine squared of alpha. I want sine of alpha, not sine squared. So I'm going to take the square root of both sides. And one side has to have a plus or minus. So now I've got that the sine of alpha is plus or minus the square root of 1/2 times 1 minus cosine of 2 alpha. But just like before, we were trying to get to the half angle formula. So we had cosine alpha before. We wanted cosine of beta over 2, or a half angle. So we're going to do that same thing. We're going to let two alpha equal beta, which means that alpha is beta over 2. And we're going to change this equation we just wrote using these betas. So I've got on the left side here, plus or minus 1/2, 1 minus cosine. But instead of 2 alpha, I'm just going to put beta. On the right, we've got sine alpha, but I said alpha was beta over 2. So we've got the sine of beta over 2. And that's exactly the half angle formula for sine. 1/2 square root of 1 minus cosine alpha over 2. We're putting the 1/2 out front, but it's the same thing. And we don't care whether these angles are called betas or alphas. It's the same formula. So now we've got the sine and the cosine of beta over 2. There are 3 forms for the tangent of alpha over 2. We can write the tangent of alpha over 2 as the square root of 1 minus cosine alpha divided by 1 plus cosine alpha, which is just the sine of alpha over 2 divided by the cosine of alpha over 2. And then we can rationalize the denominator, and we'll get 1 minus cosine alpha equals divided by sine alpha Or we could rationalize the numerator and we'll get sine alpha over 1 plus cosine alpha. Let's do one of those. So we have that the tangent of alpha over 2, let's just use this first formula, plus or minus the square root of 1 minus cosine alpha divided by 1 plus cosine alpha. And to rationalize either one, it helps to see the square root written. So this is the same as the square root of 1 minus cosine alpha divided by the square root of 1 plus cosine alpha. And I want to rationalize, let's rationalize the numerator, which means we're going to multiply numerator and denominator by 1 minus cosine alpha. I have to multiply by the square root to get rid of the square root. So in the numerator, I've got 1 minus cosine alpha times 1 minus cosine alpha. That's just going to be 1 minus cosine alpha. In the denominator, I've got the square root of 1 plus cosine alpha times the square root of 1 minus cosine alpha. Let's write that this way first. 1 plus cosine alpha times 1 minus cosine alpha. But if we've got two numbers multiplied together with a square root, we can write those as the square root of the two numbers inside. 1 plus cosine alpha times 1 minus cosine alpha. And now we can see that we've got the difference of two squares multiplied. So we've got the square root of 1 minus cosine squared alpha. In the numerator, we still have 1 minus cosine alpha. And we're going to use a Pythagorean identity, the main one, which is that sine squared alpha plus cosine squared alpha is 1. To replace 1 minus cosine squared, let's see if we subtract cosine squared alpha from both sides, we get that the sine squared alpha is 1 minus cosine squared alpha. Oh, okay, so this whole thing in the denominator is sine squared alpha. And the square root of the square is just itself. So I get that the numerator is 1 minus cosine alpha, and the denominator is sine. So that's one of the forms of the alternate forms for tangent of alpha over 2. That's the first one. And then to get the second one, we would multiply numerator and denominator by 1 plus cosine alpha, square root of 1 plus cosine alpha, and that would rationalize the numerator. So let's use one of those formulas. Let's find the exact value of all three, sine alpha over 2, cosine alpha over 2, and tangent alpha over 2, if we know that the cosine of alpha is negative 8 over 17, and that we're living in quadrant 2. So let's see. We have the this is the try this 7, and we're given that the cosine of alpha is -8/17, and the alpha lives in quadrant 2. So that's where we're going to draw our triangle. We know that alpha is always measured from the positive x-axis to the terminal side of the angle, which means alpha prime, the reference angle for alpha, is going to be this acute or less than 90-degree angle in quadrant 2. We were told that the tangent of alpha is -8/17, and I know that the hypotenuse, because I know that this is adjacent over hypotenuse, I know that the hypotenuse is always positive, which means that it's the adjacent side that must be -8. To find b, we're going to use the Pythagorean theorem. (17 squared is 289, 8 squared is 64. So I'm going to subtract 64 from both sides. And I get that b squared is 225. That's nice because 225 has a nice square root. And I get that b is plus or minus 15. In quadrant 2, b is positive, so we're going to choose this positive value. So we get that b is 15. And now we've got all three sides of the triangle labeled. That means that we can write any of the trig functions for alpha. We want to find the half angles. So let's see, because we need to know the sign SIGN, positive or negative, for alpha over 2. So let's see, we know that alpha is in quadrant 2. That means that alpha is between, let's see, alpha goes from pi to pi over 2. Is that right? If alpha is in quadrant 2, then alpha is between pi and pi over 2. Is that right? Is that what that means? And now I can multiply everything by 1/2 to get the corresponding values for alpha over 2. So I get that alpha over 2 is pi over 4. Is between pi over 4 and pi over 2. So what quadrant does alpha over 2 live in? If alpha over 2 is between pi over 4 and pi over 2. And we can just draw it. So pi over 4 is midway in quadrant 1. Pi over 2 is all the way up. So we have that alpha over 2 is between pi over 4 and pi over 2, which means alpha over 2 lives in quadrant 1. And all of the signs, positive or negative, SIGN signs, are going to be based on quadrant 1, so they're all going to be positive. And that's kind of nice. So we've got all the information we need to find the half angles. So I know that sine of alpha over 2 is plus or minus 1/2 cosine, let's see, of 1 minus cosine alpha. And we said we're going to use positives all the way across because alpha over 2 is in quadrant 1. Let's see. And the cosine of alpha is a over hypotenuse, so negative 8 over 17. And this time we're not squaring cosine, so these two negatives do communicate. So we get that sine of alpha over 2 is 1/2 of 1 plus 8 over 17. Well, let's see, in order to add 1 and 8 over 17, we need to write 1 as 17 over 17. And we get that 1 plus 8 over 17, which is the same as 17 over 17 plus 8 over 17. Let's see, 8 and 17, that's 25 over 17. And that's what I'm going to put in this 1 plus 8 over 17. So I've got the sine of alpha over 2 is the square root of 1/2 of 25 over 17. So I get that alpha over 2, the sine of alpha over 2 is going to be the square root of 25 over 34. And 25 has a nice square root. That's wonderful. So we get 5 over the square root of 34 is the sine of alpha over 2. That means that the cosine of alpha over 2 is going to have square root of 34 as its denominator. So let's cheat. Let's draw the triangle for alpha over 2. We know that the opposite side is 5 and that the hypotenuse is square root of 34. And let's use the Pythagorean theorem to find this missing adjacent side. So I know that a squared plus 5 squared is square root of 34 squared, or that 34 is equal to a squared plus 25. If I subtract 25 from both sides, I get that a squared is 9, and that a is going to be plus or minus the square root of 9. But we're in quadrant 1, so we're going to have a positive 3. Square root of 9 is 3. So we've got the 3 sides of the triangle for alpha over 2. That tells us that cosine of alpha over 2 should be 3 over the square root of 34. Let's use the formula for the half angle of cosine to see that we really do get that same value. So we have cosine of alpha over 2 is plus or minus the square root of 1 plus cosine alpha times 1/2. cosine alpha over 2 is plus or minus the square root of 1/2 times 1 plus cosine alpha. And alpha is negative 8 over 17. Negative 8 over 17. And these negatives, this negative and positive do communicate because we're not squaring the 8 over 17. So negative times a positive is a negative. So we've got 1 minus 8 over 17 in here in the parentheses. So 1 minus 8 over 17. We'll multiply that 1 by 17 over 17. 17 minus 8. Let's see, that's 9 over 17. So we get that. And we said that alpha over 2 was in quadrant 1. We figured that out already, so we're going to use just the plus. So we have that 1 minus 8 over 17 is 9 over 17. So we're finding 1/2 of 9 over 17. That's going to be the square root of 9 over 34. And the square root of 9 is nice. Square root of 9 is 3. And that's exactly the same value we got just when we just looked at the triangle. So we got that the cosine of alpha over 2 is indeed 3 over the square root of 34. To find the tangent of alpha over 2, we could just use this triangle and we know that tangent is opposite over adjacent, and that should be 5 over 3. So let's use the complicated looking formula for the tangent of alpha over 2. Let's use the square root of 1 minus cosine alpha divided by 1 plus cosine alpha. And the plus or minus is not going to be an issue because we're living in quadrant 1. So we're going to use that the tangent of alpha over 2 is plus or minus the square root of 1 minus cosine alpha divided by 1 plus cosine alpha. And 1 minus cosine alpha, let's see, that came up when we were finding the sine. We said that 1 minus cosine of alpha over 2 was 1 minus negative 8 over 17. That's plus, so we got 1 plus 8 over 17. We rewrote the 1 as 17 over 17. Oh, here it is. So we got that 17 plus 8 is 25, and then the denominator stays 17. So the numerator here, here it is. The numerator is going to be 25 over 19, and that square root is still there. The denominator, we said that 1 minus 8 over 17, that 1 plus 8 over 17 is the same as 1 minus negative 8 over 17. So we get a minus sign there, and we get that 1 plus cosine alpha over 2 is going to be 9/17. And that means we're going to multiply numerator and denominator by the square root of 17. And again, we know that alpha over 2 lives in quadrant 1, so we're going to choose the positive. We've got the square root of 25/17 divided by the square root of 9/17, and we're multiplying numerator and denominator by the square root of 17. So these square root of 17s divide out, and we're left with just square root of 25 divided by square root of 9. And that's really nice because those both have nice square roots. That's 5/3, which is exactly what we found when we looked at the triangle. So yay, isn't this fun? I'm going to stop the video and restart so that we have this whole video, this whole section is just the half angles. And then we'll look at the power reducing.